Hello everyone, welcome back. So in this video, we are going to understand the prerequisites of this problem in today contest problem, right, that we have seen in the daily series. So I have already uploaded the solution, the problem statement, understanding a problem statement, and you can say intuition, approach, and the right. But in this video, we are going to understand the prerequisites. So if you are not comfortable with hard level questions where you are lacking with the data structure concept and the problem solving skill, so let's understand here what we are going to understand here. Basically, this problem is based on the greedy approach and the prefix and suffix logic, right? So in this video we are going to understand the data structure that is used in this problem, that is priority queue, where we will understand the mean heap and max heap uses. So what is mean heap and max heap, right? Why we are going to use this priority queue in our uh, today's solution problem, right? Because see, mean heap or max heap, where we will use, where we need a faster retrieval of the smallest and the largest element, right, at the values, there we will use the priority queue. Apart from that, these are the things that is prerequisites. We'll understand why we are going to use these concept, right? Because see, if you see the time and space complexity for the heap operations, right, the heap operation saying that to add the value, you will take log n as a complexity, and to add and for the add and poll in the priority queue, right, and for overall process second and log n it will take, right. So in Java it's very easy to use priority queue, and because it will also provides you to avoid the data type overflow. So it will handle large input up to 3 into 10 to the power 5, we can say. And so it is very good to use very good data structure to use in Java also. Okay, so if you talk about the math and intuition, right, so we just need to do what we have to find the some first and some second, you will get the difference, and that is our goal to provide you, right? Means we have to minimize the difference between two parts after removing the exact n elements, right? So what should you do before writing the code, right? You should be comfortable with you can say heap, array partitioning, greedy optimization, and the Java priority queue, that is, and it should be efficient iteration, right? So at least these four concepts should be aware with. But what I understand, most of you, when the heaps are coming, right, so mean and max, either it is a mean heap is coming, or max heap is coming. If this approach is coming, most of you I'm seeing, even my student I have seen that they say, sir, how will I do that? It's very easy. Okay, so let's understand how we are going to do that. Okay, so first of all, let's understand what is heap, mean or max heap, right? So heap are two things, the mean and max heap. So a heap is a special tree based data structure that is used to efficiently get a minimum or maximum element, right? And the, you can say there are two types of the heap. The very first is mean heap, as we can see here, right? So this is mean heap, and mean heap we will use where we need the smallest element to find, to retrieve the smallest element. So the smallest element is always at the top, that is called root in the tree data structure, you can say. So every parent node is less than or equal to its children, can we see that? So we will keep the smallest element on the root, and then all the what we call element will come down, right? So every parent node is less than or equal to its children. So parent should be less than its children, less than or equal to, you can say. So mean heap, let's suppose for this array example we have given, these are the values we have given, and we want to represent, means what we need to do, means the smallest element in this is 1. So the top root element should be 1, that is always the minimum. So let's suppose this is your root element, right? So what is the next two element will be there, means there is two element, let's suppose next is 3 and 9, right? So 3 should have elements like 7 and 4, right? So as you can see, 3 is smaller than 7 and 4, and 1 is smaller than 3 and 9. Can we say that? So like this you have to represent the heap. Okay, so I hope you understand. But where we will use and why we will use, because it is efficient to find mean or max in O of one time, and that is a very good when we are using to searching, or where we want to fast retrieval or search the values, right? So let's understand how it will give you the add and remove in o log n log n time, right? So first of all, understand what is where we will use it, right? So we will use in the priority queue, right? And the problem which is based on the top k problems, let's suppose there some questions is saying find the top 5 element, top 3 element, top 1 element, right? If that type of problem is coming, where there will use the what do you call heap, min-heap, right? If you are doing the greedy algorithms, here you can use the what do you call heap, right? As we have seen in this problem, you can use the etc algorithm, and in like the problem that we have today, right? It is it. So in Java, we have the priority queue in the util package. You can just use the priority queue class, and you will provide the type. So in this case, we have the element like 1 2 3 4 5, that right, the integer. So we'll use priority queue. We'll keep to store the integer type. We will define the generic integer, and this is the min heap, where we will say equal to new priority queue to initialize the object of the priority queue. So this min heap is a priority queue object. And if you want to write the similarly the max heap, what you need to do, just use the max heap, and similarly just you need to do collections dot reverse order, right? So the operation that we are doing here, it will reverse. The same thing will happen where we will find the mean, but here it will be the max. So the top element, the root element, will be the bigger one. Here we are saying the root element, that smaller one, right? I have shown you the tree example, right? So so we are we are going to use the concept in the Leetcode 2163 that we have already solved today, right? So we will use let's suppose max heap to track the largest element in the first part, right? And if we want to use the min heap, right, that we have seen already, we have used the max heap and the min heap. So max heap will use to track the largest element in the first part, and the min heap we will use to track the smallest element in the second part, right? So this will help in removing any elements that's either, right, we can say. So we'll increase the first part, we'll do some minimally, right? Or we can say we'll decrease the second part, that's some maximally, we can say that. And so we have to we have to find like how this heap we are going to build, and how it will work when the in insertion or removal is happening, right? So this is the concept of the data structure, where you should understand the how heap builds internally, and how insertion and removal operation works on that heap, right? Let's understand how a heap builds and how it works. So let's understand the insertion and removal, how it works. So we will show you this in a minimum heap, but the process is nearly identical for the max heap, because we just need to we will do the flip operation, right? Means comparison should be flip, right? Means just you can say reverse. Suppose that we have a given input, we have to do inserts the element 53816 that we have seen. Means we want to insert very first element is 5. Means we are building the what we call heap. So very first step, we will take the 5 from this array, we can say, and the very first element we have inserted into the heap. Then we'll insert the 3. So this time what will happen, you will build the very first heap 5 and 3. So it's time to check the because the priority queue internally will check 5 and 3 value, which one is a smaller one. Means we will check 3 is less than 3, means we need to do the swap. So now 3 will go up, it become the root of the priority queue, or you can say min heap. And then we'll insert 8. Insert 8 means it will go in the next children, right? So the still the root is 3. So there is 3 is the smallest one, which is already on the top. We don't need to do the swapping. Now we'll check the insert, right? 1. When we'll do insert 1, it will go after 5, right here. So in this case, we'll check the swap. We need to swap these 1 and 5. Once we will do the swapping, we will build the structure 3 1 5, right, like this. So this we have already swapped now, right? So after the swap, you will see that 1 and 3 we need to swap. So we'll do the swapping again, right? After the swapping, 1 will come on the top, and if you'll see that there is no need for the further swap, so we'll keep this is as a max swap, right? So we'll say this is our minimum heap, right? And the minimum heap is having 1 in the top root element and the rest of the element will be, let's suppose for 1 is the root is the minimum one rather than the its children, right? Similarly for 3 is the smaller than 5 and 6 children's, right? So we can say if we will remove from the min heap, either we'll do all or peak, right? There will be a top element, let's say we'll say 1, right? So the top element, that is 1, is the our answer, right? Because we have to remove from the top. So whenever we'll do poll or peak, right, we'll see that this 1 is coming there. What we need to do, we'll replace the root element, let's suppose called 6, right? And in this case what we need to do, just replace the 6 root element, you can say, and just replace from here, right? So we are replacing the root element, the last element, right? So we'll remove this. What is the last element? Last element was 6. So 6 we will replace from 1, right? When we are removing, it means we want the position, because 1 is already removed, right? We are removing the top element. So when we are removing the top element 1, right, from the heap, it means there should be some other elements, means it will do internally heapify, you can say, right? So heapify down, we will do that, means we are comparing 6 with its children, let's suppose now this time. So we'll do internally with the 3 and 8, which one is a smaller than 3 is a smaller one, right? Means if you talk about this one for the 6, which one the smaller one, 3 or 8, which one is smaller? 3 is a smaller one, so we'll keep up here. So we see that 3 is up now and 6 and 8 will keep remaining like that. Now we'll check what 5 and 6 will check which one is smaller. 5 will go up and 6 will come here. Are you understanding, right? So final we can say that 3, 5, 8 and 6, once you remove the top element, that is 1, you will get the, you have to internally, you have to do the heapify, right? Once you will do the heapify, you will find, you will have the final what you call heap after removal. So each element we will remove from the top element. After that, it internally do the heapify and you will create the new heap, and that is that the Java will take care of that. If you write your own implementation, that then you have to think about it. But if you are using directly Java, right, you are using the priority queue, right, that is a very simple thing, right? You just use the priority queue from the java.util package and you will use the priority queue and it will internally work. How will it will know that it is working or not? You can just print the value and you can see. So for each operation on the min heap, let's suppose for the insertion will take log n, for remove or peak it will take log n, and if we'll talk about the min or max, it will take O of n. Now understand about the max heap, how we are going to understand. Just do the same logic but in the reverse order. What you need to do, just use collections dot reverse order in Java and it will work for you, right? So if you want to do the logic implementation, you just need to do what? Well, you just check whether children should be greater than parent, right? Just swap it. Okay. Now understand how heapify works for both insertion, that is called heapify up or heapify down in the min heap. Why I'm teaching you this heapify and heapify up and down? Because see, in the most of the interview, when the interview will say, okay, why you are not using the heapify? You can do heapify. They will not say you the use the min-heap max-heap, right? Just they will say heapify up, heapify down in this array, and you will get the idea, right? Related to that, they will use the term, right? So you should also understand how heapify works, right? Means if you are doing insertion, means you are doing heapify up. If you are doing heapify down, means you are doing a remove. When you are using insertion, means heapify up. When you are doing removal, means you are doing heapify down, right, in the min heap. So can we say that when we are doing heapify up, right, during the insertion operation, right, it means what? Let's suppose with the example, let's suppose we are going example 53816, right, that we have already seen, right? We are going for the insertion 5. You will prepare the root node, right? Then we'll insert 3, we'll put it into as a child, right? And then we'll insert, let's suppose uh, further, right? What we need to do, swap, right? Before that, we'll check 3 and 5, which is smaller than, right? Then we'll see that this 3 is smaller than 5. We'll do the swap that we have already seen, right? Then insert 8, you will check the insertion, you will see that no swap is needed, right? Then we'll check 1, now the swap will require, right? So we'll check 1 and 5, we need to do swapping here, right? Similarly, we have created our what do we call, the heap. After we have to do 1 and 3 will check, we need to swap this value, right? So after the swapping, you will see this is the value we have, right? After insertion 6, we'll see that there is no need of the insertion. Means this step we have already seen, right? Very first we have prepared what, the root node, then we have inserted these 3, and then we have checked both are 3 is less than 5 or not. If 3 is less than 5 means we have to do swapping, so 3 will become here, it will become root element. Similarly we'll get 8, so we'll just put the 8 here in after the 3 here, right? So no swap is needed. When we are adding the smaller value, it means what, it will check from the value, right? So it will check 1 and 5, it will check with the parent. Similarly we'll do the swapping. After the swapping, it will get swapping the value, then we'll check 1 and 3, 1 and 3, it means we'll create like this. Okay, next we'll create insert 6, so it will check no insertion is required, no swapping is required, and this is our final heap, min heap. When you are doing the heapify down, means during removal, you just remove the element 1, right? What you need to do, you are replacing 1 with the last element, that is 6, right? So what you need to do, just you replace the root element, that is 1, with the 6, you will have this element. Now you have to do comparing with 3 and 8, which is a smaller one. 3 a smaller one, will keep this 3 in up and 6 will come down. Similarly we check with the 5. Now we have to, you will check 5 and 6, which is smaller. 5 is smaller than the 5 will put on the up, right? It means for heapify path, right? Let's suppose for insertion 1, what you have done here, you just put here 1 and you did the what do you call, heapify, right? And when we are going to heapify down, means after removing 1, the element was like this, right? We have removed the 1 from here, so the element we want to replace is 6, right? So we'll keep 6 here, and then we will do we'll check the heapify down, means 6 will check with the 3, right? 3 will go up because it's a smaller one, it is going up here, it is up now. Now we'll check 5 and 6, which one is a smaller one, so we'll check, it is smaller, put it up. You will not do anything here because it is already larger one. Okay, so how does this works in Java, right? So in Java we know that we have heaps, right? We'll use min or max, which are very common while using the binary heap that is stored in the array, right? So there is a standard library that is called Min-Heap with the priority queue, we can say. Let's break it down how we are going to use it. So if this is your priority queue, you will just write the priority queue integer heap, right? And you will write like the code here. So on the min-heap, you will add min-heap.add. Add is a function of, or you can say method of the priority queue class. So we'll add one element, it will go to the priority queue. So you will keep adding the priority queue like this, right? So what will happen? All the element will be get added here. Just you need to do while not equal to min heap dot is empty, right? If it is not empty, you will print the value min dot poll, right? Means you are keeping, you are removing the element from here. So you will see that when you do poll after adding all this value, right, you have ordered first time 5, 3, 8, 1 and 6, right? Second last is the 1, but when you are doing poll, you are seeing the first is coming 1, then 3, then 5, then 6, then 8, like this, right? That is why it's very important. And to use this priority queue, you just need to import java.util.priority queue. If you are using the Leetcode, that's fine, we do not need to import it because it's already imported. If you want to write the custom heap class, right, you just need to write the class min heap. Why I'm saying that, you may need to, let's suppose they're saying you don't need to build the use the internal heap, right? So how you are going to implement, just for understanding, they will not say this one, but let's suppose someone is saying to implement you the custom heap. How we are going to implement the custom heap? You'll take the heap as a array, and there will be the size, right? Then there will be a constructor that will initialize these values, right? Then there will be insertion. At each insertion you will use the heap at size, that is called val, and you will increase the you can say heapify, right, up. Then when you are doing heapify up, means you are increasing the size. Okay, so let's suppose you are doing the remove min, right? In that case you will get the what is at index 0 at the heap, you will get that element, right? And then at heap at 0, what you will do, heap at minus minus, the what is the second last element, that is at minus minus, you will get that element. Okay, means from the last element, I'm saying from the last element with the first element you will replace. Means if you are removing 1, now you are getting the 6, right? This will give you the 6, and this is 1 at one position, means root element who will come, the 6 will come, that we have seen, right? The last element. Okay, then we'll do heapify down, you will do heapify down and you will return the mean. Okay, similarly you will do heapify up, right? In that case you will pass I, you need to find the parent I, like this, I minus 1 by 2, right? And then do heap at I should be less than this value, right? Okay, so just you do the swapping, the reverse thing that we have seen, right? You just do the reverse thing, right? You will get the, you will do, if the heap at I is less than the heap at parent, means you have seen the value, right? If it is like heap at element is less than, or you can less than the parent, means it should replace, right? Let's suppose this the what you call, parent is 3, but heap at I is 1, it means we have to do the swapping. So this is a swap function, right? You just need to swap the value. This is your I, you will update the I, right? So parent now become I minus 1 by 2, just do it, okay, I minus 2. Okay, similarly you will do the heapify up, and this is your heapify down. It is similar to the binary search, right? You remember. So here you will define what you call left and right, and the smallest element I, you can say, and you will check if it is heap at left is less than the smallest one, you will find the smallest one, means we have to find the smallest one, like a binary search, right? That you will do that here, and you will get the smallest one. You are doing the heapify down, right? And this is your swap function, three variable we will use, and we'll do the swapping, right? And so what is our note from our side, means the heap is very important for you, right? And it internally works how, like that, like the complete binary tree is working, right? Like that we will use, right? Because the heap is a complete binary tree stored in the array, you can say, right? For node at index I, the parent is I minus 1 by 2, left child is 2 into I plus 1, and right child is 2 into I plus 2, right? These are the things you should be aware with, because this is the property of binary tree, binary complete binary tree, right? So this allows you O of log n time for insertion and removal without using the explicit tree code. Okay, so I hope you will continue this video to understand. Please go and watch this video today, and give a thumbs up, like, and subscribe. Also uh, support ExpertFunda by liking and subscribing this channel, and share with your friends who preparing for the interview, flying interview, right? If you want to get any help from me, you can contact my number. Thank you guys, thank you for watching this video.